So welcome back to the LLM Context Engineering Bootcamp. And today we are going to be discussing about Model Context Protocol, tools, function calling, and how LLM can do all these things with natural language instructions and what are its applications. So today's will be one of the most exciting lectures simply because you will get to see the power of Model Context Protocol and what it can accomplish. This was a term which was extremely popular around April, May of 2025 last year on X.com and LinkedIn. Everybody was talking about MCP. Whenever I opened LinkedIn, it was flooded with just posts about MCP. And now it has become more than just a fad. It's like it's truly, truly useful to you for many different applications. So my plan is the following. We will first discuss a little bit about the aspects of handling different tools by LLM, because usually when you are building a agentic applications, there will be several functions or several tools that the LLM should get exposed to for performing certain operations. But you cannot pollute the context of the LLM by adding too many things into the context. So you have to be very frugal when it comes to how the descriptions of tools are being exposed to the LLM's context. So first we will discuss about that a little bit. And then my plan is, unlike last three lectures where we did the quiz part in the end, I might probably do a little bit of MCP related quiz in the early part of today's lecture, because I have noticed that many people, this is when I read different blogs and articles from Reddit and so on, there is a lot of confusion surrounding what is MCP client, what is MCP server, how do LLM interact with either of these, what is the role of each of these three parts, and what are some applications of this. So I hope that through the quiz, a lot of these things will get clarified for you. So first, let's just recap what we did yesterday. So yesterday we were discussing about RAG, and RAG is a select layer of the context engineering layers. Select meaning you are selecting what should be part of the LLM's context. In tools, it's more about LLM deciding, okay, what can I do next? I have so and so information, and now what could I do with all of this information, right? Just one update. Yesterday's recording will be uploaded in the free course dashboard by today around 2 p.m. or something like that. And today's will be available tomorrow. So just it's a minor update. All right. So today we'll discuss how do we define tool schemas when you have 10 tools or 20 tools or 50 tools that the LLM is getting exposure to. Then we will discuss about model context protocol, how it blew up the internet a few months ago and why it has become such a standardized protocol where LLM and any tool can interact with each other, any LLM and any tool. And what exact problem does MCP server and MCP client solve? And can you do something without MCP? What's the problem of not using MCP in the first place? We'll discuss all of that. And we'll also see how the anatomy of an MCP server looks like. So I'm planning to show you two examples. One is a case where we will use an already existing tool with the help of MCP from Cloud Code that I will show you first. First or second that I'll decide on the go. Another thing which I'll show you is like the entire anatomy of a very simple MCP server, which has a very useful function. So I'll get to that in some time. So I have one question to ask. Let's say you have something like 7,321 multiplied by 8,761. You are multiplying two numbers. If you have this as part of your query, will you directly ask this to the LLM or should you directly ask this to the LLM? You can answer in the chat. What exactly should you do? If you directly ask the LLM, what's the problem? The problem is that, see, LLM is not a sophisticated math calculation engine or something like that, right? It is simply a next token prediction model. LLM is not really, really strong at doing mathematical calculations like multiplication, division. It can do that. It will most likely won't make any mistake, but sometimes it has the possibility of hallucination. And a simple deterministic calculation like this may also result in error if you are assigning this duty to the LLM. Instead, this duty should be assigned to whom? Who should take this duty of executing a mathematical operation like this? it should probably be done by a function in which addition, multiplication, bunch of those things are defined, or like a calculator tool, right? You could have API access to a calculator tool, right? So if you as a human, if you are building a website and in that website you want to execute a complex function and this function is hosted on a server side, what you typically do is like you design an API and then you make an API call request and you will get the response, right? So the execution is not done from whatever logic you have on your website. It is rather done by the function. Similarly, if within the context of an LLM, it just so happens that it needs to execute a mathematical operation. Okay, just a random example. It needs to execute a mathematical operation. Ideally, LLM should figure out that, hey, I probably have to call a tool, calculator tool for executing this without any mistake. So that is where the idea of tools are coming into picture. LLMs, let's say you want to access information, like there are tools will expose weather related data, right? So there are APIs using which you can get weather data. And if you want to display today's weather on your app, let's say you are running Blinkit or you are running any grocery delivery application, you will see that it also reflects the weather. If there is rain happening, it reflects that it's raining. How does it happen? That app has access to some API which exposes the current weather conditions, which are constantly updated in some sort of database. So they will most likely be using some proper weather app API. Or if you need to, let's say, on our website, for example, we have a function where somebody can switch the currency from INR to USD or vice versa. So how does the website know what is the current exchange rate between USD and INR? Again, it's an API call. It makes an API call to some financial tool which exposes the current exchange rate. So similarly, LLM has no access to live data. Live data exists on internet. It exists on different websites. And if those websites allow access to those data through APIs, LLM should be able to somehow access it. So these are actually tools. Second is LLM cannot do actual computation. LLM is only good at next token prediction, but all other capabilities that LLM has, like LLM can write code, LLM can actually do math. I mean, in theory, it can make mistakes, but in practice, it can do math, right? LLM will make mistake only once in a while. In 2022, if you have noticed towards the end, if you ask ChatGPT basic math questions, it was making a lot of mistakes. But these days, the mistakes have reduced tremendously. So, of course, the emergent properties resulting from next token prediction when you are scaling up the large language model, of course, it is increasing. But yet, you would mostly, if you want high reliability, you will rely on computation tools. Then the third thing is LLM cannot make any changes or any effects in the real world. For example, LLM by default cannot place an order on Amazon. LLM by default cannot send an email. For sending an email, you use any email sending tool. You use Gmail API or some setup like that. LLM cannot directly send a message in Slack or in Discord. For that, you may use MCP for Slack, or you will use a API service, right? So LLM do not have access to live data. It has no access to computational tools, or it cannot make any change in real world directly by itself. But rather, if it has exposure to tools, it can do all these things. And one thing you should notice is whenever LLM makes a tool call, if LLM makes a call to a weather condition retrieval tool, the result of the tool will be stored in the context only, because the tool will send the result back, and then that result is compiled in a certain way before feeding into the LLM, so that LLM can give you natural language response saying, hey, the weather today is likely not very favorable for you. You should probably not go out. And that will be stored in the context as well. So of course, you have to have some window available for storing the tool results also. Okay, this is just an example. Yesterday, we had discussed that RAG results will probably take up to 60%. In this example, it's only showing 30%. But don't get hung up on the percentages. It's anyway a thumb rule. But here is the issue. If you have a tool that is that has so many different capabilities, for example, let's say you are making an LLM talk with Slack. Slack has so many different functionalities. You can create channels, you can assign admins, add members, delete members. You can post, there are many things you can do in Slack. So now think about this. Let's say as a result of your LLM interacting with Slack, if the response is something like a 5,000 token JSON, it's very big. 5,000 token roughly equates to 5,000 words, not exactly. I'm just saying order of magnitude wise. And this is too big for a context window of the LLM. You might not need these many tokens to be fed into the LLM for you to get the response that you need. Let's say the question that you are asking is, in the general channel, what was being discussed yesterday? Can you give me a 3-sentence summary? If this is what is being discussed, the JSON need not contain information about how to create channels, or it need not contain information about all the other channels. So the token consumption by LLM should be ideally minimized, which means whatever a tool is returning, or whatever the description of a tool is, or whatever information is there associated with the tool is, it should be stored in a concise format so that LLM's context is preserved. There is a question by Abhi. How is a RAG result different from tool result in this example? Both have knowledge based on live weather, right? Okay, very good question. Think about this. In RAG, what we are doing is we have documents that are not necessarily live. These documents are converted into some sort of vector embedding, right? So the vector database itself is not getting updated very frequently. And then from that database, you might want to fetch information once in a while, and you want to analyze that information using RAG. So yesterday, what did we do? Yesterday, we took the PDF file from the Microsoft shareholder report. That shareholder report is not going to change anymore because it's a already done 2025 shareholder report. So now from that document, you might want to fetch and analyze information. For that, you use RAG. But let's say now there is another tool which is also having real-time updates of the Microsoft stock price. And if you want to fetch that, that is when you truly have something like an MCP. You can think of having an MCP server. We'll discuss the definitions and details in a little bit. But RAG and MCP are fundamentally different in that way. MCP can have access to real-time data, and it will be agnostic to what LLM you are using to connect to an MCP server. We'll come to that in a moment. So when it comes to LLMs interacting with tools, you need a tool description. LLM should be able to decide what tools among all the tool descriptions should I use. And then LLM should figure out how to make a call to the tool. When the tool returns some response, that will be taken into account. And then final response in natural language, so that the user who asked a question, let's say you are asking a question about a mathematical operation, or you're asking a question about financial data, you finally want a response from the LLM just like it is a human. So this response will be crafted. Now there is a fundamental question. Who runs the tool? Is it LLM? Who is actually running the tool? So think about it. When we say LLM having access to tool, what exactly is LLM producing as the output just before the tool is being executed? I'll repeat the question. A tool, you can imagine a tool to be a function, right? That function, you will require arguments to be passed into the function. When we say out of 10 functions, LLM decided to call function number 3, LLM is not executing the tool. LLM is deciding the LLM's output decide the structure of how the tool call should look like, along with the arguments that we pass into it, right? The actual execution is done by the logic of the logic written inside that function itself, right? So please understand that LLM is not running that. LLM is deciding what tools to call and what tool to execute, and it produces a structured response as a result of this decision. Okay, that structured response will be used to call the tool. So this is one place where LLM will produce a response which as a user you will not have to see, but LLM will produce a structured response, and that structured response will decide what tool to call and what argument to pass. And then the tool will return its response, and the final sort of structured or unstructured response which is exposed to the user is coming at the very end. Okay, so this is the LLM's decision producing a structured response for tool call. This is also LLM's decision to kind of display the final outcome in whatever format is required to the end user. Okay, so just understand this. Now, a tool schema which describes how a tool looks like, or what a tool should do, or what variables to pass, or what this tool is even capable of doing, whether it is searching of weather data, or whether it is searching of US dollar to INR exchange rate, whatever it is, the schema can roughly look like this. There will be a name. And the convention is that if a name is there, it should ideally mention the functionality. The functionality is searching. So functionality and some sort of description about where this functionality is applied to in this format. So this is called as snake case. Whereas if it is something like search products with capital P, what is this called? It's called camel case, right? If I'm not wrong. So the name of the tool will be in this kind of a snake case. Search is the action that it is doing. Products is what it is searching. Then the description will be in natural language. It will describe what this tool is capable of doing, which is already available some sort of to some extent in the name, but description expands it. Then it will also describe the different properties. It will, if it is a function, it will describe what arguments are being passed. If there is a category selection, it will enumerate the category so that LLM will not hallucinate something outside of this category, most likely. LLM can still hallucinate anytime, but this will tremendously reduce LLM's hallucination if these are the only categories that LLM should consider. And many other details, right? So this is a rough example of how the schema in sort of JSON format, how it can look like. Now, the schema design principles, as we discussed, just look at this. The description, which tells what the tool is supposed to do, should be clearly saying this tool is supposed to search the product catalog from this website database, and it is ideally returning the maybe top 50 items from the database. There is one question: is tool and MCP, are they the same? Are they different? They are different. Tool you can imagine as just a function. So we are yet to reach to the MCP. Okay, I have not defined what is MCP yet, so just don't get confused. Here, if I talk about tool, just imagine that within your, let's say, if you are writing in Cloud Code, within there you have written, let's say, 50 functions for different activities. Now your LLM has to decide for your execution which among those functions it has to execute, which among those functions it has to call. For that, you need to have some sort of description of the function itself rather than apart from the actual function. Actual function will be written, let's say, in Python format or JavaScript format, but you need to have some sort of description so that LLM can decide which one to call based on a short description. So here we are talking about that selection of functions to execute, okay, in simple words. Then one more thing is make sure that your name of the tool or name of the function is unambiguous. This is a better convention. This is better convention. This is better convention. But if you write it something like search products or something like this, it's not considered to be a good convention. And this enumeration, if it is a categorical variable that this function is supposed to be handling, explicitly enumerate those categories into the tool description. That will help a lot. We'll see how these descriptions can look like. This we have already discussed. The tool description will help the LLM decide what tool to call, and then it will produce a structured response, which will also include the arguments to be passed. And then tool will be called or tool will be executed. And it will, at the end of it, if it's a function, it will return a certain value. And once this returned value is available for LLM will reason based on that returned value. And then LLM can give you a response which you can utilize, right? So this is the 5 steps involved in it. We'll see this in detail when we are going through an interactive website, just like how we were doing in the last couple of lectures. One more thing I want to discuss before we move into the MCP is what if you have 100 tools or 1,000 tools? Each tool description may be around 100 to 200 tokens, or maybe 100 to 150 words or something like that. So if you have 100 tools and each tool description is 100 to 200 tokens, you may end up consuming 2,000 tokens or 5,000 tokens or 10,000 tokens, depending on the tool. Now imagine you are building a complex software. Your complex software will have so many different functionalities that if you are now handling all those tool descriptions within the context at once, your context will definitely become bloated. So a good practice is On the lower extreme, if your number of tools are very low, okay, then you can include all the tool definitions inside your system prompt. It is not a problem. However, if your tool descriptions are so big just because of the sheer number of tools, you have to do some kind of RAG where you will have minimum description available. From that minimum description or minimum available metadata, your RAG can decide which 5 tools or which 10 tools you require during the execution of the current task. So in that case, you have to utilize RAG. The RAG can be using vector database or it can be using keyword matching. It does not matter. But at the end of the day, the descriptions that are loaded into the context window will be only a subset of all the tool descriptions available. This is the other extreme. Regarding just-in-time instructions, JIT, we will discuss towards the end of this the set of slides. This we'll come back to in a little bit. So now we can get into model context protocol, where anyway, by default, discussions about tool will come. First of all, let me ask you, how many of you have heard about model context protocol before? Or how many of you know about what it is? Or what, I can ask you one more follow-up question. Seems like some people have heard about it. Okay, awesome. Now, please tell me, in 2 sentences, what is the fundamental difference between model context protocol versus, let's say, making API calls? Let's say you have an MCP server in one case. In another case, you have a server which has several APIs. What's the difference between having an API call executed versus making a handshake with a MCP server to get data or get whatever you need from the tool? The fundamental difference is that different LLMs handle API calls and responses from it in a different way, right? And the LLM, if you want to really switch between Gemini or OpenAI or LLMs provided by any other companies, you need some sort of standardization. So I'll come to this definition, but before that, let me show you. So what happens in the absence of MCP is that this N by M problem. If you have N LLMs and M tools, by M tools, you imagine softwares, GitHub, Slack, your company is using this, and maybe Docker, maybe you also have a Firestore database. You have a bunch of tools. And let's say your company uses 3 LLMs. Then what will happen is, in the absence of MCP, if you want to define interactions between your LLM and tools, you may use API calls for sure, but then you will have to write the structure for these interactions N by M times. For interaction between Cloud and GitHub, you will have to define. Between Cloud and Slack, you will have to define. Between Cloud and database, you will have to define. But when you utilize MCP, model context protocol, what it does is it standardizes the way in which instructions are sent into this MCP server. It standardizes the way in which instructions are sent back from the MCP server, this protocol, which means it doesn't matter which large language model you use. There is a common way of communicating with the MCP server to provide information to the MCP server and to get a response from it. And this makes the life very easy for developers, because that way developer need not think about a developer who's let's say building an MCP server need not think about which large language model the user is going to use. It makes it very easy. So that then the problem becomes sort of like N plus M. You have to set up 3 MCP servers, and you have to set up the connection to the MCP server for each of these 3 LLMs, right? Now, there are 2 things here. One is MCP client, and there is MCP server. The best way to understand the difference between these two, I will ask you a bunch of questions, and at the end of those questions, you will have a very clear idea in your mind what is the role of MCP client and what is the role of MCP server. Okay, I'll come to that in a moment. But there is a beautiful analogy that you may have seen in the internet about MCP server, which is that of a USB-C port. So before USB-C, you had many different ways in which your devices can be connected to whatever charging point or to a laptop. You remember, like maybe 10 years back, Windows laptops, they have many different ports for connections for HDMI, VGA, or then there is USB. Before USB-C, there are other variants of USB connections, micro USB. It's like a pain, but USB kind of standardized this so that in my MacBook, in the same port, I could connect mouse, I could connect like a converter for USB-C to HDMI. Oh yes, I will check the waiting room. Thanks for the reminder. Yeah, I have just admitted. Thank you. Or I can convert my USB-C connection into anything else which connects to that separate tool. So now my USB-C port will act as a connector between my laptop and projector, my laptop and mouse, my laptop and let's say this Wacom tablet, or my laptop and mic, anything, right? So it standardizes this connection problem between two different hardwares. Just like that, MCP server standardizes the connection between different tools or different software with your large language models. Now, what we can do is, before we go into this further, I will first show you one simple MCP tool which I had defined recently. Okay. Can you see my screen right now, which says a YouTube MCP? Okay. So what this does is the following. So here I have defined two things. One is an MCP client, which is a website with some URL. So let's say this is YouTube MCP.com. So this MCP client is basically the web app. And this client runs on Vercel. Okay. Now, what this does is, I will just show you the front end of this application so that you have a better idea. What this does is, this is a simple application which looks like this, where if I provide the OpenAI API key, and if I provide the YouTube URL of any video, so here I have taken the link to the second lecture video itself. And if I provide the video link here, then I should be able to fetch the transcript, or based on the transcript, I should be able to generate lecture notes, or I should be able to generate key points, or summarize what happened in the lecture in one paragraph. All right. So here what is happening is, the OpenAI API key provides access to GPT-4o mini or one of the LLMs. Then what is the tool that is being used here? If any of you can tell me, what is the tool that LLM is accessing to from the MCP server? The tool is basically a tool which YouTube library provides for fetching the not summary, transcript. That is the key distinction. Just let me go back. The only tool used here is for fetching the transcript. Is the tool creating the lecture note, or is the tool creating the key point, or is the tool creating summarize? None of that is done by the tool. The only role of the tool is when my client meaning when this website asks to fetch the transcript, okay, or when it asks to fetch the lecture notes, what it does is, this client makes a call to a server in which a server.py file is running. I'll show you the file. Where is the server hosted? For the time being, I have hosted it on railway.com. Now, this server, so this is the MCP client, and LLM is or GPT-4o mini. And this is the MCP server. And the tool is, let's call it as get transcript. Okay. Now, what we want ideally is, manually, how will we do this? Manually, if we were using ChatGPT, what will we do? We will somehow run this somewhere, this get transcript function, if it is available on our VS Code in a Python file, we'll just run it. We will provide the YouTube video URL, and we'll get the transcript. And then we will copy paste the transcript to ChatGPT, and then we'll ask, hey, based on this transcript, create a lecture video description or lecture notes or lecture summary, right? Here, on the other hand, when this is the client itself, what you see right now is the MCP client, in which, let's say you click this lecture notes button. What happens is, there is this YouTube URL which is provided to the client. this URL is communicated to get transcript. And there is one more step that happens before this, which is called the client server handshake. I should also mention that probably first. Let me just draw this a bit far away. So the very step that happens in the communication between server and the client and server is the server client handshake. In this handshake, the only information that will be passed from MCP server to client will be that, hey, here are the list and descriptions of the tools that I can provide you. And based on that, the client can decide what tools. Client can help LLM decide what tools to call, right? So this first step is called the client server handshake. After this only, the actual tool calling will happen. So the handshake will happen automatically. It's part of the protocol. And there are two ways in which communication can happen. I will show you two examples, one example of both. In some cases, your client and your server might be on the same device. Can you give me an example of this case? Can you give me an example of a case where your client and server may be on the same device, like on my computer? Any example where this might be the case? Local LLM, access file system, database MCP, file server. So one good example you can think of is, let's say you have a software that is installed on your device. To make it very simple, I'll show you an example. Okay, let's say the software is Blender. Have you heard of the software Blender? It's a 3D modeling software, very good software, right? Let's say this is installed on your computer and you are using Cloud Code on your computer so that Cloud Code can communicate with Blender to create 3D models or to create scenes. Okay. Normally, for a human to create scenes in Blender, even for experts, it will take a lot of time. I'll show you a very good example here. Now, but the thing here is, here Cloud Code is running on your computer. Blender is also on your computer. So the MCP server as well as MCP client. So this is the client and this is the server. Not Blender is not the server, but MCP server, which will connect to different functions available in Blender. Both are running on your device. In that case, the communication protocol between them is called STDIO communication protocol. But if this is happening through the internet, like this example where client is one website, which is hosted on Vercel, the server is MCP server is basically a function that is running on Railway in the backend. Here, the communication protocol can be HTTPS, just like how it usually happens on internet, or SSE, or sometimes it can be socket, WebSocket. HTTPS is the most common one. We don't have to go into the details of this because it's not what is relevant, but what is relevant is to just understand that the way in which the client and server will communicate will slightly differ based on whether the places where client and server are hosted is the same device or different devices across the internet. Now tell me what will happen when I ask my client, who is the website where I pass the OpenAI API key and I pass a YouTube URL. What happens is, first, the client will pass the YouTube URL such that this to the LLM, such that the LLM will decide a definition of a tool call, in the sense that there will be a structured output coming out of this, where it may say the tool that I have to call is get transcript, and the argument that I have to pass is this YouTube video URL. And then this will be passed using HTTPS request, used in the form of HTTPS protocol into the MCP server. And what does the MCP server do? MCP server will access this get transcript function into which the YouTube URL is passed. This get transcript function, in our case, if I go back, there is one more function that the get transcript function is calling. I will show you the structure in a moment. I don't want to go into the detail right away, but it calls a function called extract video ID. Basically, given a YouTube URL, this function can extract the ID of the URL, and that ID is needed to finally fetch the transcript. So then this function will fetch the transcript, okay? And that fetch transcript is now the data that is being passed from the server back into the client. So now, usually, what is the format in which the data or the communication happens when you do an API call? What format document is usually passed in an API call? It's usually JSON. But here is my question. What if, as part of the API call, you are also getting a video file or image? Is that passed through the JSON, or is it just referenced in the JSON? It is referenced in the JSON. It will be just streamed as data, right? Similarly, here the JSON or the format of the response will talk about the metadata of what the data is being passed, but the actual data that is being passed from the MCP server to the client will be what? Will be the transcript. Now, if from our tool, if we were asking to summarize, now one more question. Where is this transcript passing? Is that going into MCP client, which is Claude code, or is it going directly into the large language model? This transcript that we get from the server. Does it go to the LLM or does it go to the MCP client? It goes to the MCP client always. Why is that? Why should it go to MCP client and why not to the LLM? Because LLM only wrote the structured structure for calling the function. So why not put the response to the LLM? The problem is, let's say your MCP server ended up giving you a huge output. This server is not the guy who is maintaining your context window of the LLM. Server does not care about the LLM's context window. Server only cares about returning what is asked. The guy who is caring about your context window is whom? Who cares about the context window of the LLM? MCP client cares about the context window of the LLM. In this particular case, the client is the Claude code itself. I mean, not in this case, in the case when I am using my local device. But in this case, the MCP client is my the logic of my website. Okay. And then this guy will decide what to ask my LLM to do next, provided this output which it received from the server. So server will communicate to the client. Client will decide, with this available data, what all things should I pass to my LLM? Then if we had clicked this button for called summarize, it will pass two things. It will ask in the prompt, it will pass the transcript, as well as it will pass the command that you have to summarize this transcript into a one paragraph. If we had clicked this key points button, it will say, make a bullet pointed list of items which were discussed in the lecture based on the transcript, and then it will also pass the transcript. Yeah, there is a question. Can you please explain the difference between MCP host and MCP client? Yes. It's an ongoing discussion. So I will ask you many more questions to make it clear. One more thing is, let's actually, before we go ahead, let me ask you a few questions. I think this will clear a lot of confusions about what is a server, what is a client, and so on. So let's get into a series of questions. In the model context protocol architecture, what is the primary role of MCP server? So in MCP architecture, there is server and client. Store the conversation history, replace the LLM when tools are needed. What's the role of MCP server? Clearly, it is D. MCP server provides the tools as well as any other resources which the client can access. Next one. Where does tool selection actually happen in MCP workflow? Who decides what tools to select? Is it the server or is it the client? One more. Is it the client or ultimately it is the LLM? Ultimately, it's the LLM, but it will happen inside the client because client is having direct access to LLM, right? Then what is the main purpose of the tool schema that the server sends to the client? This is in the initial handshake. Initial handshake, the schema of the entire tools that are available will be sent, or even with an individual tool call, a schema is sent from server to the client. Why do you need this schema? Without the schema, how does the LLM know what kind of format response to produce to make a tool call? LLM does not know, right? You have to explicitly teach the LLM otherwise. But if the schema is exposed saying, hey, here is how the function call should look like, here are the arguments that you should pass to this function, and these are the purposes of this function. If you tell this to the LLM, then LLM can produce a structured response call which will invoke the function call from the in the MCP server. So it tells the LLM how to call the tool. Next, if LLM decides to use a tool, what does it actually produce? Does it produce a Python function, which is the tool itself? Does it produce an answer to the user immediately, which is exposed to the user, or does it provide a response in natural language, which serves as a request to the server? None of that. It produces a structured tool call. And where does this structured tool call go? Where is it going to? It's not going to the client. We have already passed the client stage, because client will give enough information to the LLM to give the yes. In the beginning, client has to communicate with servers for sure. Ultimately, it's going to the server for sure. So this is a structured tool call which the LLM produces. Next is, what condition must be true for a tool to be usable by an LLM by an MCP client? The tool must expose a schema describing inputs and outputs. Tool must be written in Python. Tool must run inside the LLM process. Tool must return JSON embeddings. There is no restriction that it should only give as a response JSON embedding. So tool must expose a schema. It should describe what the inputs are, what the outputs are. In the inputs, also the arguments will be explained. What is the main role of the transport layer, such as STDIO or SSE or HTTPS in the MCP? So this transport layer establishes a protocol for communication between the client and server. When is STDIO used? When both the client and server are locally, it's within the same device. Otherwise, you could use SSE, HTTPS, or WebSocket. So this is a protocol for transferring messages between the client and the server. If an MCP server exposes 10 tools, but the client sends only sends the LLM only 3 tool schemas, what will happen? So server communicated to the client that there are 10 tools available, but client decided to send only 3 tool schemas to the LLM, which means the model will only be able to access those 3 tools. So think about this. Model LLM is only communicating with client. LLM is not directly communicating with the MCP server. All the communication between server is with the client. And then all the communication of the LLM is with the client. Then after a tool runs on MCP server, where does the tool result go first? Is it into the LLM itself, or is it to the user, or is it it's back to the MCP client? Because this is why we have established a communication protocol between the client and MCP. Why does MCP separate the client and the server instead of having just the LLM call these functions directly, or maybe API call? Why can't the LLM directly make API call or something like that? The basic idea is that this will allow any LLM connect with any tool with using a common protocol. So it makes the life of the developers so much more easier, right? So it allows external systems and tools to be accessed safely and modularly. If an MCP server exposes a tool, but the LLM never sees the tool schema, what will happen? So who decides whether LLM should see the tool schema or not? MCP client decides. So MCP server exposed a tool, but LLM never got to see the tool schema. Then basically LLM won't be able to access the tool, right? Because the tool schema is never visible to the LLM. So LLM has no idea about the existence of the tool in the MCP server unless the communication happened from server to client is also communicated to the LLM. Which component in an MCP system actually executes the tool code? This is a very interesting question. You have a code for executing there is a function or the tool. Who is doing this? Because the tool, who has direct access to the tool? Client does not have direct access to the tool. LLM does not have direct access to the tool. Direct access to the tool is only for the server. So server executes the tool, and whatever results are there, it will pass on to the client, right? If a retrieval tool returns multiple documents, who decides what portion of these documents go back into the prompt for the LLM? This is easy because everything, what should go into the context of the LLM is decided by MCP client. So if we have Cloud Code as the MCP client, and if we are using Opus 4.6, what goes into the Opus 4.6 model is decided by the MCP client. Now, which component maintains the conversation loop with the LLM during tool usage? So I can see A and B. So conversations with the LLM is always done directly by the client, right? Tool directly does not communicate to the LLM. Server does not directly communicate to the LLM. Only client can directly communicate to the LLM. In our example, Cloud Code or our website, which is hosted, it can communicate directly to the LLM. The website is hosted on Vercel. Then, besides tools, what else can MCP server expose? This is something which I haven't discussed yet. I will come to that in a little bit. I'm jumping the gun here. But MCP server can actually expose three things. It's called three primitives: tools, resources, and prompts. So I will just go back to my Miro board once just to show you that there are three primitives which are part of a model context protocol. So this is the way in which the server will expose tool at server. Let me just change the color. At server.tool followed by whatever function. This exposes tools. At server.resource, this exposes the resources, which are documents. And then at server.prompt, this will expose predefined prompts. I will show you one example where this is kind of done in our YouTube MCP. So here, let me show you the folder structure. So here you see bunch of folders. What I have done here is both the client and the server, I have written the code here and I push the code to GitHub. But whatever code is available in this web folder, this is the website that I have hosted on Vercel, which acts as the front end. So this website, YouTube MCP Git main, this website, okay, this button definition, this style definition, and the way this OpenAI API is stored in the local storage, all of these things are defined in this inside this web folder. So this web folder has nothing to do with server, but it has got everything to do with what? This folder has nothing to do with server, but it has everything to do with the MCP client. Here, the MCP client is this web app itself. So this web app acts as the client, and this folder defines the client, which means when I am deploying on Vercel, only the contents of this folder is deployed from GitHub. So I will change my root folder as the web folder in Vercel, and then Vercel can automatically fetch whenever changes are made to this folder. And when I push it to deploy it on GitHub, Vercel will refer to this folder on GitHub and it will redeploy. Now, the files that are primarily used in the MCP server, which runs on Railway. So I'll just show you on Vercel. This is how the deployment looks like for my front end. And on Railway, where is Railway? On Railway, I have deployed the backend. The server, which is active like this. This is referring to primarily these two Python files, primarily this server.py file. So let me just show you server.py and its structure. So first, it is importing a function called fastMCP. This is inherently for implementing things related to the MCP, the communication protocol, etc. So this is by default. But another thing this server.py is calling is one is LLM utilities, LLM utils, which we have defined manually here. And this will help us switch between OpenAI or Gemini models. So here I have given two options. So in the front end, I had given two options, OpenAI or Gemini. And when that switch is made, that change should also reflect in the way server sees the model, right? Or server knows how to communicate with the client. So to the provider, which is the, to the client, I have to say what LLM is being currently used. The LLM that is being currently used is either OpenAI or Gemini. And then in the server.py, I have three things written here, which are several of them are redundant actually, So the redundant things are, I'll tell you what are redundant, and maybe you can tell me yourself. Oh, okay. There is a question. Why should the server know about the LLM? So basically here I am passing the API key in the server function. In the MCP tool function here, I am passing this. And this is being passed into this ask LLM function. Ask LLM is over LLM utils. So basically, whatever function this LLM utils is exposing, and that function has details about what model is being used. And it's not that, okay, I think earlier I said the server is directly getting access to the LLM. Yeah, I'll come to the redundancy part, but basically just to explain this, the server is getting access to a function which says these are the models and these are the parameters. Ideally, these things could be defined, I think, in the front end also. I could simply say the definition of the LLM and the definition of the model can be done in the front end, and server gets exposure only to the client. But the way here it is written is in such a way that this function is being exposed to the server.py. That's the only reason why I have to write in the LLM utils the providers which LLM is being used at the moment. In the server, can I show you in a zoomed out way? I don't know if you can see this fully. Can you just tell me which tool might be redundant here? So the reason why I have written this is to show you the three primitives, the tools, the prompts, and the resources. But so, and then just see this. The only function that this tool or the prompt or the resource is calling is get transcript function. Get transcript function is being imported from the other Python file, which is YouTube tools.py. In the YouTube tools.py, this get transcript function gets the video URL. Video URL is passed into this function called extract video ID. Extract video ID based on the URL, it will check if the URL consists of certain pattern. And if the pattern is matching, it's a valid URL. And then it will fetch the ID of the particular video. And the ID of the video is stored in video ID, which is passed into this YouTube transcript API function. That API is imported directly from this library, YouTube _transcript API. This is provided by YouTube directly. And one thing here, which was interesting for me, is there is no need of any YouTube API key or something. This function directly allows anyone, even without YouTube API, to directly get the transcript of a YouTube video. So here, ideally, I don't need any of these functions. Like I don't need these resources. I could simply comment, I don't need the prompt. The only reason why I have written it is to show you that if we were having prompts and if we were having resources as the primitives, how the function will look like. Let me just comment this. The only thing that we need here is look at the client. What all tasks are client asking the server to do ultimately? Or what all things are client asking the LLM to do? Client is asking for creating lecture notes. Client is asking for key points. Client is asking to summarize, and client is asking to get the transcript. In ideal case, in a different way, if we implement this MCP client and MCP server, a different way of implementation would be for fetching the transcript alone, one communication happens between the tool and the tool and the client. And then everything else, summarization, key points, lecture notes, everything happens on the client side. Here, one thing you notice is like the way this is defined, which is not ideal, is that there is one tool, mcp.tool, for getting video transcript. There is another tool for summarizing the video. There is another tool for defining extracting the key points. There is another tool for generating notes. Now tell me, was it necessary that I define these three tools on the server side? These three tools, should it necessarily be on the server side? It should ideally be on the client side, right? There is no need for me to do these actions on the server side. And this is the reason why, if we come back to the earlier point, because these functions are executed on the server side itself, the LLM access is provided to the MCP server in this case. But this is not an ideal practice at all, right? Yes, in this case, we will need, if these tools are defined on the server side, and if the definition of this tool is to call an LLM and do a certain function, of course, the server should require access to LLM. Yeah, so just to clarify, let me just draw this. So MCP server is there. MCP client is there. This is the Vercel website. And this is the railway deployment. In this particular case, one thing that will confuse you is the server is finally returning the final output. It returns one of the four things. It returns transcript, or it returns summary, or it returns, let's say, lecture notes, or it returns, I think, bullet pointed outline or something like that. And there could be one LLM over here which can decide what to do with this. MCP client can ask the LLM, hey, here are the lecture notes. Do this with the lecture note. Hey, here is a summary. Do this with the summary. Hey, here are the bullet points. Beautify the bullet points. But this part we are not doing yet. What is being done is MCP client is interacting with the MCP server. This server, as part of its tools, it has four tools. Get transcript. Yes, all results can be derived from the transcript. So there is no need for having these three tools in the server side. But right now, the way it is defined is there are four tools: get transcript, get summary, then get bullet points. Forgot the name of this, but something like that. Then get the lecture notes. Okay. And all these tools, out of the four tools, this and this require an LLM access. This does not require an LLM access. This is directly getting it from YouTube. Now, if you were to design this in a different way, what you should do is remove all of these tools or all of these functions from MCP server, because this is unnecessarily requiring a communication with LLM, and move this here. And when the communication happens between server and client, remove all of this and just ask the server to do one function. The only one function the server would do is get transcript, which does not need any LLM access. This is purely a YouTube function, YouTube call, API call. And then pass the transcript to the client, and then ask the LLM here on the client side whether I should summarize it or whether I should convert it into bullet points or lecture notes. Okay. But here in this example, get transcript is the only tool which I can show you. So I thought we could display more tools if I also add some additional tools here. Okay. So the confusion that was created earlier was, initially I said, why do we LLM will never communicate with the server. That is still true. LLM will never communicate with the server. The LLM associated with the client will only communicate with the client. But if the server tools have access to its own LLM, that communication can happen, and client does not have anything to do with that communication. If MCP server functions also got its own API call to make to a different LLM, it can do that, right? So in this current case, the reason why these in LLM utils, this provider is written, the OpenAI and Gemini is written, is because these functions for extracting, summarizing video, extracting transcript. So here you see in this extract transcript, there is no LLM call coming. But here in summarize tool, there is this ask LLM call coming. In extract key points, it is coming. In generate notes, it's coming. So what does this mean? It simply means the following. This tool has access to an API call to YouTube, whereas this tool has access to API call to where? LLM. This tool has access to API call to LLM. So does this tool. That's the only difference here. But then on the client side, you will mostly in most cases will have its own LLM, which will decide or which will be asked to do whatever you are supposed to do with the output you get from the server. So if you were to redesign this particular tool or this particular application, what you should do is you should delete these three things. Simply delete these three things. Just keep only one tool. Keep only the get video transcript tool. Then the only communication that should happen between client and LLM should be pass the transcript. And then eliminate this LLM utils, because this is also not needed, because the server need not know about LLM. Server has nothing to do this with LLM. Why? Because server is not even calling any LLM. So just comment this line. No need of LLM utils. You can delete this file altogether. This LLM utils completely delete. On the server.m, only thing that is running is this MCP tool. And then this will communicate the transcript to the front end. And then from the front end only, the LLM API call is made for executing, whether you need to summarize or whether you need key points or whether you need lecture notes or whether you need to just purely display the transcript which you directly get from the server. If you purely want to display the transcript which you get from the server, you don't even need the LLM. All right, you can just directly display. Only server is needed. Does this client-server architecture restrict client to only read from the server and not able to write to the server? That is a good question. Right now, to the server, what is happening is not writing. To the server, what is being passed is the function call with the arguments. So Amit, when you say writing, you mean to say, can something change in the database of the server as a result of the communication that is happening between client to server, right? That is a good question. I think writing can happen, right? That is what is happening in, but at the end of the day, writing is done by the tool. It is not done by the client. So client can, to give an example, let's say you build a chatbot. So yesterday I was building a chatbot for Discord. Now this chatbot will act as a bot and it will post comments or reply. It can do whatever on Discord or Slack or whatever. So there, the tool is in essence, the tool is making changes to the database on the server side, right? But it is not directly done by the client. Client is simply communicating that to the server. Server is making the appropriate tool call. The appropriate tool call may make changes in the database, or it may read the data from the database. It's up to what we have designed the tool for. Okay. Now I want to show you one more thing, which I don't know how many of you are aware of, which is the power of MCP. So I'll show you one YouTube channel. So we actually have a YouTube channel called Visual Learning. Okay, this is anyway our side business, in the sense like this has got nothing to do with AI or anything, but it's a good channel. So our team basically makes these amazing 3D visualizations, explaining science concepts and those kinds of things. And most of these are made using Blender, and some things are additionally added using Unity. Now, the good thing is the quality is very high, but see, a human's effort is needed to make stuff like this on Blender. It's very, very time consuming, but it has a huge impact on, small kids who finds it difficult to visualize these concepts otherwise. So now I'll show you. This is the Blender software. I don't know how many of you have seen this Blender software. Can you see Blender software, by the way, right now? Are you seeing Blender or are you seeing something else? Okay. Now, I don't know if I have to zoom in a little bit. Let me try to zoom in. Yeah. Do you see something called Blender MCP here? So this is one of the latest versions of Blender 4.4.3. There is something called Blender MCP. What you can do is you can start an MCP server. Right now, I have started it. It says the server is running on port 9876. So now the way this structure is in the following way. We have, let's say, Cloud Code. And say my requirement is this. I want to make such beautiful visualizations and animations without touching the Blender, just using natural language. Okay. So I have Cloud Code, which is the MCP client. Then I have LLM, which is Opus 4.6. Then I have MCP Blender MCP server, which is the MCP server. And then I have Blender itself, Blender and different functions or tools within the Blender. I can maybe write like create 3D model or whatever the tool name is. There will be like hundreds or thousands of functions in Blender. So this is the tool. Now what I need to do is this. I will talk to my client and I will say, hey, make this kind of an animation, render it on Blender, right? The name of the YouTube channel is this, Visual Learning. It's an amazing channel. I don't know how much utility this will have for you guys, but this is mostly for folks studying in like 10th grade, 12th grade, etc. It's a nice channel. Anyways, so now coming back to what we do here. So here, let me switch to the. So can you currently see this Blender agent, or are you seeing some other screen? Are you seeing this Blender agent VS Studio VS Code? Okay. Now let's do something. I have already set up the connection. Setting up the connection part is easy between Blender and your client. That Cloud Code will take care of itself, right? You don't have to do something special or anything, but basically this is how it works. First, let me check if the connection with MCP server is still live. So this is only connected, this client is only connected to Blender MCP. It's not connected to any other. Now we will say, okay, let me clear all the context and let me say something like this. I want to make a new scene rendered as a 5-second video using EV instead of cycles. This is just a rendering format. EV gives cycles is very realistic, but very slow. EV is less realistic, but it's very fast. You don't have to know about that. I want the rendering to happen in 2 minutes. So select the resolution accordingly. And then here is the description of my scene. I want to make an animated scene that shows, let's say something like, can you tell me any science experiment which won't take too much time to render, something that is neither too complex nor too simple? There are many concepts, eddy current, but something which you prefer, anything. Okay, refraction, running on, just jumping on moon, photosynthesis, atom molecule. Okay, atom molecule sounds very much doable. Refraction, the only issue I know is if you render something that looks transparent or something like that with a different medium, it will look a little bit weird with EV rendering. Then we need cycles rendering, but cycles rendering will take a lot of time. Okay, simple harmonic motion, I really like. That shows simple harmonic motion using, let's say it's not a pure spring mass, it's a spring mass damper also is there, spring mass damper system. Make sure that the lighting is a little bright, but not overexposed. Also make sure that the camera is pointed at the experimental setup. All right, so just this is a very basic thing. Ideally, what we should do is, so we have still not yet created a single Blender animation for our YouTube channel, but this idea occurred to us only like this week or last week, and our team is experimenting. How much can we teach Cloud Code to learn the patterns of our previous Blender renderings? Because all we can do is we can provide the previous Blender files to Cloud Code and ask it to create markdown files like skill.md files, which will summarize our general Blender skills, right? Our team's skills. Like this is the way in which we do the lighting. This is the way in which we define the objects. And when we define constraints between the objects, this is how we define. So it can create enough skill.md files to kind of capture our style of making. And then ideally, I can give very little number of experiments to sort of, a very little number of sort of instructions to create something in our own style, right? So it's a very interesting tool. And, we even recently tried this with CAD. So there are a lot of CAD softwares where people are designing actual machinery, right? And those companies, the thing is, those companies are still, the companies who use CAD is still running years behind. I mean, they are not running with the latest AI tools in their arsenal or something like that. So there is a lot of scope for disruption just by introducing um, sort of these tools to such companies, or even helping them set up such workflow. One more thing is, I was recently having a like this was 3-4 weeks back, having a meeting with a company. What they are trying to do is they're trying to create you might have seen these companies where there are 3D renders of any house. So if you're trying to buy a house or rent a house, many platform provides you 3D renderings through which you can you can do a walkthrough. So it's actually a difficult problem because there are more houses and more apartments for which such a 3D render does not even exist from camera photos. But you could imagine creating a workflow where you go to an apartment, and from the apartment you can click large number of photos in different angles, or you can even take a 360-degree camera, and then you can have a setup where all your preferences of how 3D modeling should be done using whatever software you use is mentioned to the Cloud Code. And then that software, you can make the connection to the software using its MCP server. So literally, if you think about the industries that are being disrupted right now because of this kind of workflow, is so huge. It's just that some of those companies will take time to realize that things are changing at such a fast rate, including us. I mean, we were like blown. I did not know last year when we checked something like this for Blender, output was not at all good. Like what it was doing was, I mean, you could write Python code, and then that code you could import to Blender, and that code will render something on Blender. It's not very what do you say, uh, it's not possible to make complex renderings using that. But this time it was very mind-blowing. I'll show you some sample outputs if I can find it over somewhere here. But what I'm trying to say is, most of the modern tools, right, they have its own MCP server. I will show you one uh, GitHub repo. Okay, there is a question. What are being communicated between the Cloud Code and MCP server? Basically, Cloud Code is communicating to the MCP server its function call. So if the function call involves creating a square-shaped object of certain dimension, let's say the dimension and its XYZ position are the arguments. The function, that particular function call is being passed, and then the Blender tool will execute it, the tool which is meant for creation of the object. So at the end of the day, whether you are implementing this scene, see the scene is getting created as we speak. It's amazing. It's not easy. So the spring mass damper system is here. It's not easy for a human to do this. It's very, very time consuming. And this is with our very primitive prompt. We have not followed any standards. Like our prompt is like very, very basic right now. But now imagine what you could accomplish if the prompt was detailed, if all your preferences are stored, and this will also be animated. I'll show you once the render is complete. Um, it's completely disrupting every industry. So one thing you should try is, I don't know how much your company, wherever you're working, allows you to use different tools. But my opinion is, I have tried many different AI coding agents. Cloud Code and Codex are above the one league above every other thing which you can use. So if your company is not allowing you to use it for whatever reason, security or whatever, at least in your personal capacity for something which you want to build yourself, you should use it. Otherwise it's a big loss in my opinion. This GitHub repo actually has a lot of different MCP servers for many, many different purposes. So you can scroll down here. There are many interesting MCP servers people have created, and you can deploy it yourself also, or it is already deployed for various tools, as well as for various various famous softwares, as well as for other random tools. So just check this. This has 89K stars. There was actually one more GitHub repo for MCP servers, which I don't have. I don't remember on top of my mind, but I'll show you. But anyways, let's check if what happened to our rendering. There is a play button here. So you see this right now. I'm playing this on Blender. It is showing the spring mass damper system, right? You should know how difficult this is to make in Blender, something like this. It's for somebody who's a beginner, or even someone who knows this Blender in and out. It's not a child's play to put these objects, and some people have very poor 3D visualization skills also. And to animate these things, to define constraints between different objects, because now this cube has to move along with the spring as the spring is getting compressed. So there is a question, can Blender generate videos as well? Yes. So that is what I'm going to show you. So this animation that is being played will be stored as a video. I have asked Cloud Code to render it as a video. You can render an image, which will obviously be faster. This video will be like a 10 or 5-second video. My computer is a little bit slow right now because of the rendering, but I'll show you. Now think about softwares which are used in traditional industry. Maybe like a logistics handling software in hospitals, or in some softwares used in big company inventories. The problem is that if those softwares are internal softwares, somebody has to create the MCP server if people need to use LLM along with it, if they want to use LLM along with it, right? And somehow, yeah, our company is blocking to use MCP due to security. Is the MCP the only way to do? Can we have our own way to do MCP using function or tool calling? MCP is the best way to expose a tool to an LLM. But the thing is, you don't have to host the MCP server anywhere in a publicly accessible way or something, right? It can be purely internal. And if you are worried that your MCP tool may erase some data in your data set, so I had recently created an MCP server for modifying some content on our own website. Our website backend is in Firebase. And usually we have to go through the front end of the website and make some modifications. Let me just, my screen is frozen actually. Let me stop sharing my screen. Can you hear me all right at least? Or is my screen is a bit frozen? I think this render is taking time. Okay, but you can hear me all right without break, right? Okay, thanks. So I'll just continue speaking. Let the screen come back to normal once the render is complete. But what I'm saying is, one of the issues that I had was, if I create tools for editing, let's say a course, or deleting a course, and then let's say that tool is MCP server is exposing that tool to my MCP client. What if I accidentally say something and then that thing deletes an entire database or something like that? So I was worried about that. So then what I did was, I defined the MCP server such that the functions for deleting or editing are having much more guardrails. So that guardrails are on the client side. Before the client even produces the instruction to delete or edit, there is a triple check I have added. So me as a user, I have to confirm 3 times before something like that is sent to the server. That is one option. Another option is eliminating that altogether, eliminating the ability of the MCP server to make deletions altogether. I'm not able to actually even switch off my camera because my screen is entirely frozen. Let me just give me a moment, guys. Let me close Blender. Anyways, this is the problem with using Blender while you're doing a bunch of other things. One more thing you can do is you can install Blender on a remote server like EC2 or something. The same thing you can do on that so that your local computer is not getting, hung up. But yeah. Actually, let me kill this process. You don't have to see the video to believe me, right? I'll show you some other videos, but this is fairly straightforward. The point being is, I think there is a good money making opportunity in different industries if something like that interests you. One thing you could do is like find industries that are still relying on softwares, and those softwares which is like a real big pain point for its users. It need not be customer facing software or anything. It can literally be softwares for internal purposes. It can be softwares which are for managing inventory, or sorry, managing invoices on say using Salesforce, or it can be any other tool which causes a pain to a large industry, to a large number of internal users. And now see where you can produce disruption, introducing some sort of system where you have an MCP server and client setup. So it's like it's truly, the thing is, people who are so used to the software sometimes will not agree. That they'll say, hey, this issue is there, that issue is there. Of course there are issues, it's there is no doubt about it. But the thing is, the world is moving in a direction where um, people are embracing AI more and more. There are even terms like AI native. I don't know what it even means, but people keep on saying that from different companies when they have meeting with us. We want to become AI native team. But whatever it is, they want to build internal tools which also has AI capability so that you can interact with it in natural language, just like how I interacted with Blender in natural language. Can this produce an output as good as a 5-year experienced Blender professional guy? Maybe not, but that is not the point, right? In future, it can. It depends on how you set up the client. But the server is perfect in the sense that the server is having perfect access to every single functions that Blender has to offer, just like how the Blender UI is offering you functions with mouse button clicks or with keyboard presses. Just like that, the MCP server is perfect. Now the question is, you as an AI engineer, can you design a perfect MCP client which can interact with the server and get something which is truly valuable? I think that is where a lot of skill is in these days, and there is a lot of opportunity to disrupt many industries in this way. I mean, this is just one example. um, okay, then I want to show you one more thing. That is the idea of just in time instructions. Let me first close my cloud code. It's slowing down a lot. Just give me a second, guys. I'll just close every single thing and make sure that my system is not slowed down. Oh, the reason why it was slowing down was because this animation was playing, because it has to render frame after frame in Blender. So that takes a lot of CPU. Uh, I forgot to pause the animation. I should have just paused it. All right. Anyways, now let's come back to the session notes. So this is the basic architecture. MCP client will be desktop or web app, or cloud desktop or cloud code or web app, and it can access the server. Communication will happen in JSON format, the basic communication, but through STDI or HTTP protocol. And then server will have access to a bunch of tools. Those tools will execute the task, and then the results are again sent back to the client. There is one idea which I skipped earlier, which is this just-in-time instructions. So just-in-time instruction, the idea behind this is, I think Anthropic only pioneered this. Anthropic or Shopify, I forgot the company. But basically what they said is, if a tool has instruction associated with it about, okay, once this tool is, once you have the results from this tool, this is how you can utilize the instructions from the tool. Let's say you have such a description about the expected tool results, and let's say those descriptions are quite big. Usually what you do is, those descriptions are all written along with the rest of the tool descriptions. If you have 50 or 100 tools, your system prompt will become massive, because all those tool descriptions you are loading into your system prompt. And because of this, you will have context rot, right? But the approach in just-in-time instructions is, if there are things you have to take care of, once you have the tool results, you don't write those things in the system prompt. Instead, you let the MCP server itself return something called as JIT instructions, just-in-time instructions, which will be an additional field among your results. So the rest of the things will be results, okay? And then there will be JIT instructions. And then, this is two-way also, by the way, that there could be JIT instructions which are passed along with the tool call to the server, okay? To the when the LLM is producing the call, and server may have an LLM, or server may have a inbuilt robust logic, which is not LLM based, but which is keyword based. So LLM, the server can refer to the just-in-time instructions, and based on the just-in-time instruction, which will be deterministic, server can decide what to do with the tool results before passing the tool results to the client. That is one thing. So that the tool results that are passed to the client will be much smaller. And then the client can have a much cleaner thing to pass to the LLM. And in the opposite way, when when the server is deciding to pass a particular result to the client, it can add deterministic JIT instructions. The reason why I say deterministic is, there is no need of an LLM logic there. This instruction can be purely added using an enumerated list. Yeah, can you give some concrete example point how MCP server will provide just-in-time instructions for sure? So this is client, and this is server. Okay. Now JIT instruction is just-in-time instruction, which will help us. The only role of that is, only goal of that is to save the context window of the LLM. We don't want the context window to be polluted with a lot of unnecessary tool instructions. If there are 50 or 100 tools, the server is not going to use all those tools at once. Even if it's using multiple tools, the instructions only corresponding to the most important tools of that moment need to be exposed to the LLM. Now, who is doing this? Client is doing this. So client decides what goes into the LLM. But then LLM is creating a tool call, right, in a structured format. This will make a tool call in a structured format. So there is one way in which you can add a JIT just-in-time instruction. The LLM can decide to add a just-in-time instruction in a specific format, which will tell the server that when the server is returning the results, and let's say there are 10 tools that are being called right now. And let's say one of the each tool is returning 50 values each. Okay. So there will be 10 times 50. By default, there will be 500 items or values that are returned from server to the client. Now, when client is getting this much, the client is also having to have some logic before deciding, out of these 500 values, what all things should I pass back to the LLM, right? So instead, what we can do is, the just-in-time instruction created by the LLM during the tool call can be simply, hey, when you are creating the results, just give me instructions, give me the result regarding, let's say, parameter A and parameter B. And the way this JIT is constructed will be in such a way that it is something that the server also can understand, right? This will not be in natural language. I mean, it will look like it is natural language, but this definition will already be there in the server side. Then instead of the server returning 500 values from this 10 tools, maybe it will return 10 multiplied by 2, 20 values. And when these 20 items are now being passed into the client has a much easier time filling the context of the LLM. Otherwise, client has to implement some other logic to decide out of these 500, what are the most relevant things to be fed into the context right now. One more thing that is often done is on the server side itself. Let's say this is the result that are passed from the server. There could be just-in-time instructions which are embedded in the results which are passed into the client, which will say how to interpret this particular set of results. So let's say in the results, there are 500 parameters. Okay. And just-in-time instruction says, if you care about only 99% accuracy, consider only the first 3 params. Then this makes it very easy for the client to decide, okay, only first 3 params are decided. Then it can truncate and feed the result to the LLM, right? So this just-in-time instruction helps at the end of the day in reducing the LLM's context window size. Not the context window limit, but the tokens that fill the context window. There is a question, client could initiate tool call with LLM. Client cannot, can you repeat the question? Client can initiate tool call with the LLM. I mean, LLM decides who creates the just-in-time instructions. On this side, LLM creates the JIT instructions. LLM can add it on along with the tool call structure. On the server side, JIT could be embedded in the result in a deterministic way. There could be JIT instructions which are, let's say, there are if based on if-else condition. If this is the case, JIT is this. Else, if it is case B, JIT is this. Like, for example, if there are 500 responses coming from the tool, JIT should be only top 3 are relevant. If only 10 are coming, only everything can be relevant. All 10 can be relevant. Then who instruct LLM to use JIT? That is part of the instructions provided to the LLM by the client, depending on how the client is set up. So it's up to Cloud Code, right? If we say that we want to follow a schematic where just-in-time instructions are used rather than utilizing the instructions about every single tool available, we can do this. So one more thing is, if there are 100 tools to the LLM, you typically don't have to should not be dealing with 100 tools, right? So yes, JIT basically is a dynamic thing which is added depending on the total number of tools that are needed to be considered. If only 5 to 10 tools are need to be considered, it's not a problem to add the descriptions of the entire tools operation and how the result structure may look like. You can add all of those things into the LLM context, because the total number of tokens this may consume could be between 500 to 1000 or something like that, which is kind of okay. But if the size of the context window or number of tokens is humongous, like 5K to 10K, because of large number of descriptions of 100 to 200 tools, in that case, you will decide out of these 100 to 200 tools, whether we need only 5 tools or 10 tools or a group of tools. To give you an example, in Slack, there are tools that are related to channels. There are tools that are related to messages. There are tools that are related to users. There are tools that are related to pure admin related things, or like making people admin, or removing members or adding members, etc. Within each of these group of tools, there could be 100 different functionalities which are different functions. For example, within a channel, there are many things, right? You can rename the channel. You can maybe change the channel ID. I don't know if it is possible. I'm just making it up. You can copy the channel ID. You can invite a user to the channel. Now think about this. If you have a group name for the list of tools in the tool description, channels, users, then let's say admin. If the current task that the LLM is talking about in the context has something to do with sending message in a channel and nothing to do with DMing a user or something like that, then the only tools that the LLM needs to ask client to execute in the server is channel related tools. And maybe there are only 5 tools in this group of channel related tools. In the users, maybe there are 15 tools. In the admin, there are 25 tools. Like that, maybe there are 3,000 functions which the Slack has. Now, and with these 3,000 functions, you should not be loading all of the descriptions of these functions into the LLM's context. Now, how will the LLM decide whether I should load this group, or I should load the users, or I should load the admin? One of the way to do that is by following the just-in-time instructions coming from the last tool result from the server. Then LLM will know what the context of the current tool result is. If the user has been added to a particular channel and a new welcome message has to be sent to the channel, then the LLM can switch the focus from the group of functions called users to group of functions called channels. Then if a welcome message has been sent, then maybe if the LLM has to now notify the admin with some email or whatever, then the LLM can switch its context from this group of functions in the channels to this group of functions in the admin, right? Basically, it's a way to save the context window. The good thing is in cloud code and modern coding agents, most of these things are taken care of automatically, in the sense that its ability to manage context window is so good already. We will not be implementing JIT in code right away, because that will be extremely time consuming. I want to show you one activity actually. Let's go through that. I will share a link with you. So can you open this link? So this is an activity which will show you in a concrete way what are the schematics of different tools. Okay. Yeah, so resources and prompts. So resources are the documents that we will come to that actually here. The resources are basically the documents that that can be communicated between the server and the client. For example, if there are tool descriptions tool descriptions provided from server to client, and there are, let's say, 500 tool descriptions. These tool descriptions can probably be stored in a document, right, in some format, maybe in JSON format, in a structured document format on the client side. And then client can decide to run a RAG on those resources to feed only the top 5 tool descriptions into the LLM's context. So resources is a broader term saying it is not just tools that are there associated with the communication between LLM and the client and the server, because client and server normal communication is what? Normal communication is simply the tool result that is passed. But in the initial handshake, which will happen between the client and the server is passing a lot of information about all the tools it has at its disposal, right? So those things can be stored as a resource, which can be referred to later. If we come back to this example of getting the transcript. So let's say we are executing the transcript to summary in such a way that first the client gets the transcript from the server. Then that transcript is stored as a resource, as a markdown document or something. And then from that resource, let's say you are suddenly now asking a question, find the paragraph related to discussion about RAG from this transcript. Then you can actually run a retrieval augmented generation using keyword search or using embeddings to find the relevant paragraph from that huge transcript, because a transcript of a 3-hour video will be long. But that resource which is stored on the client side can be utilized for feeding the information to the LLM. Now, where did this resource come from? Primarily, it came from the interaction that happened between client and server. Now, prompts are repeatable prompt system prompts which you can use again and again and again. So in our case, the prompt that is used again and again and again is the button click. So when we click the button summarize, it is utilizing a particular prompt. If we click the button create lecture notes, it's again utilizing another system prompt, right? So when we say there are three primitives to the MCP, the three primitives are the tools, resources, and prompts. It simply means that there are a bunch of tools or functions that are defined on the server side, which the client can access. There are a bunch of documents which may be exchanged as part of their communication, which can be utilized later as a resource. There are several functions that the LLM can execute through client to the server by repeating the system prompt with a button click or something like that. So the resources and prompts are stored on server side or client side. In the current example, it is stored on, it is ideally stored on client side. The repeated prompts are at the end of the day passed to the client. However, in the way we have implemented it, if you remember, LLM was on the server side, which means prompts are on the server side. And the resource, which is the transcript, was passed from the client server to the client. And that transcript we did not store anywhere because we were using the same transcript to we were calling the transcript function again and again to get the summary or get the bullet points. But if we are storing it somewhere, it will be stored on the client side and not the server side. Let's actually go through this function. There is a question: can the RAG can be wrapped in a tool call? That is a good question. I think so. So your question is, if there is a function, can a RAG be implemented within that function, right? That is essentially what you're asking, right? Yeah, I think so. I mean, at the end of the day, RAG has got not much to do with LLM, right? RAG is purely you have a query, you have a bunch of documents. Documents are in the form of vectors. Query you convert into a vector, and then whichever documents are closest to this query, you just fetch it. So it has got not much to do with LLM, which means it can be, yeah, for sure, it can be implemented as part of a tool or as part of a function. So RAG can be, tool can wrap around a RAG for sure. All right. Now let's open this document, and here I'll just keep the bright mode. Yeah. So here, basically what we are doing is, this is like a imaginary company. It's called Astrolog. It's a fictional space logistics startup. And then we are designing tool schemas. We are designing MCP server configuration, and and React agent loops. Okay, React I should explain once just before going ahead. So React simply means reasoning and acting. So this React framework was also popularized somewhere in the half of 2025. The basic idea is this. LLM will make a tool, will create a tool call structure. The tool call will happen. Tool will provide results, right? Then the LLM has these tool results as the observation. Then it can think on this. It can have a reasoning layer based on the results. We will see a solid example in 2 minutes. And then based on this reasoning, it can decide, oh, should I call another tool? So this is tool number 1, this is tool number 2. And this is result set 1, reasoning based on result set 1. Then this will say results 2. Then the LLM will again reason based on results 2. And then the LLM, after these results are there, then it can provide the user response, right? So the thought is the part where LLM will reason. Action is the part where a tool call structure is initiated. Observation is when the tool call results are injected into the LLM, and then the LLM can reason on top of the results. And then finally, in this loop, at one point, LLM will decide this loop can run 2 times or 3 times, and then only LLM will produce the final output which the user can see, right? So let's see this in a visual way. So right now, what this particular Astrolog company does is it basically manages the logistics behind, let's say, space exploration. like a fictional thing basically. And our goal is to design tool schemas. So tool schemas will be utilized for LLM, MCP server configuration, and React agent loops. And all are running on client side in the browser. Okay. Now, first is tool schema. There are two tool schemas. For mission search, there is a tool schema. And it's basically to get what are the ongoing missions or upcoming missions. Crew schedule is if there is a space crew who is traveling for those missions, what is their schedule. Cargo manifest is what is the cargo that is shipped into the space along with the mission. Fuel estimate is, okay, for this mission, for the current status, for current situation, what is the estimate of the fuel remaining? How much can this mission last? So let's first just compare the two schemas. One is a vague schema and one is a well-defined schema. I will not show you the well-defined schema yet. Just look at this vague schema and tell me what is vague about this. What's the issue with this kind of a schema? This is the schema of which describes that of a tool. Okay. Is there any issue in the name? So name is not in that snake case format we earlier discussed, right? It should be like get mission data or something like that. So in well defined, it will be like, this is a good name, search missions. Now in the vague schema, what is this description? This is the most lazy descriptions. Basically, this lazy thing is what we just did when we implemented Blender. But here in well-defined schema, the description of the tool will be search missions is the tool name. It will search the Astrolog mission database by keywords, status, etc., and returns this so and so. And look at this thing. What is this queue? Properties queue string query. This is the worst schema ever. But actually, this property, it says where is that? It's a query. Query type is string. Search keyword to match against the mission name, destination, or crew names. So basically, in a well-defined schema, one issue is there will be more tokens that are consumed. Obviously, the number of tokens in this tool schema is maybe 1/3 or 1/4 that of the number of tokens consumed in this schema, or maybe half of it. But this is much more useful to the LLM. Now, same thing applies for crew schedule, cargo manifest, fuel estimate. I don't have to show you that. Another thing is this design principle. This we had already discussed. A good tool name should contain a format which looks like this: verb noun format. So search mission is search is the verb, missions is the noun. Okay. Then there should be clear description about what we are supposed to do with this tool. So if the tool is to get missions, it should not just say get missions, gets missions. It should explain in a little bit of detail what the details of what goes into the tool. And what comes out of the tool. It returns matching mission with status, crew, and destination used when the user asks about mission, launches, or destination. All right. Then enumerating constraints is if we want the LLM to consider only certain string values, instead of just saying, let's say the status of the mission, let's say that is the variable. The status can be planned, in transit, completed, delayed, aborted. Technically, yes, all these are strings. And but the problem is if we just say bad, if we just say type, it's a string type. This is very bad because yes, it is true that this is string type, but there are only so many types of mission statuses. It's not infinite. So LLM, the opportunity for the LLM to hallucinate is minimized when you enumerate the available the string inputs. Then the next thing is required versus optional. So sometimes some tool calls will not require all the different arguments, right? Some arguments are already inbuilt. One example is if we are using calling an LLM, or if you are running, if you are building the, let's say, backbone of an LLM, one argument could be how many layers this LLM has. Sometimes the number of layers will be by default decided as 6 layers or 12 layers, which means it is okay if you can skip that parameter. So it is very important to say what parameters are mandatorily required and what are optional, because if you mark everything as required, you are forcing your LLM to come up with some values to this required field, which will again force the LLM to hallucinate. So just mark whatever parameters are required to be passed into the tool, mark that as required. Whichever is actually optional, mark those as optional. Then return descriptions is document it documents what the tool returns so that LLM knows how to interpret and present the results. So this returns is basically showing what this tool or function will return. It will return the list of missions as an array. Inside the array, there will be ID of the mission, name of the mission, where the destination is, status, current status, launch date, the crew who went on the mission, etc. In the bad case, this description of the output format was not described. Then low parameter count, keep parameters under 5, combine related fields into objects or use sensible defaults. More parameter equal to more chances for LLM to make error. This is in tandem with what we discuss here. Here also we are constraining the options that LLM will have to choose from, whereas here we are leaving it open. Then another principle is this just-in-time instruction, and here is an actual example of just-in-time instruction. So let's say the function that you are calling is calculate fuel estimate. And this function will return an output in a JSON format, something like this. Fuel kilogram is 52,500. The cost of this fuel in USD is so much. The safety margin is so much. Now, when before this tool result is being passed into the client, you can add an instruction. I mean, the server can add an instruction saying JIT instructions. Important when presenting fuel estimates, always note that 15% safety margin is already included. If fuel greater than 50,000, one that this requires a heavy lift vehicle, present cost in millions. Example, $2.6 million, not like this. Suggest checking weather at the launch site. So basically, this is the JIT instruction that is coming along with the this particular tool result. And this will, in the downstream, save a lot of, I mean, not this particular example. What I'm saying is, in general, JIT instructions will save a lot of the tokens. Same for, this is another example for a different tool. This is a get weather forecast tool. It will return the weather at a certain location. What is the condition? What's the wind speed? Whether it is safe to launch or not. And then the associated JIT instruction, if the result is JIT enhanced result. Right. So this is just to show you one example of how the just-in-time instruction is actually added into the result. How is it injected along with the result? One more thing we can see is, so this is the whole pipeline. You describe what the tools have. We saw this in the JSON format. LLM decides what tools to call, whether it is get fuel estimate or get the weather report, right? And then after decision, LLM will call. And then after the call, the tool will return the JSON format return. And then if there is a React loop, LLM can reason on top of that result, which I will show you in a moment. Now let's move on to the this part. So this is how the rough MCP architecture looks like. This we have discussed in detail. Even if you skip this is okay. But basically there is a host. There is a client that the host talks with. So in our case, the host is the web app. The client is basically on the web app itself. Client connects with the server, and the server is in Railway. And then communication happens between client and server. And let's look at this server builder, okay? So I will first just do one thing. First, remove all of this. And let's do one more thing. So just look at how the 3 primitives for the MCP server looks like. So the 3 primitives are tools, associated resources, associated prompt. So let's say the tool is search mission. We are only caring about searching for missions. Then that will be added into the JSON, which is communicated between the server and the client. And then in the resources, we can add the resources related to the missions. It could be a log from the astrolog, which is a document that enlists the missions active or not. And then there could be a crew schedule associated with the mission. And then in the prompt, there could be like a already defined prompt. Here, the definition of what this mission brief is not mentioned, but the system prompt could be, here are the mission details. Here is the resource document. Based on this, create a 2-sentence or 3-sentence brief of the mission, right? And this is how the final JSON format will look like, in which all the 3 primitives are embedded: prompts, resources, and tools. And this is the initial handshake, what is shown here. Initial handshake, if you just click this play button, you can see client will ask the MCP server to initialize. MCP server will respond with its own capabilities, tools, and resources support. And then once this is received on the server side, the connection is active, connection is complete, meaning now the client is ready to interact with the server to execute tools. And transport is, this is how there is one more thing I want to show here. Tool call flow. So tool call flow look like this. Client will ask for a list of tools, server will respond with the list of tools. Client will call a specific tool or specific set of tools, server will execute the tools and return the results. Fairly straightforward. And this we have already discussed. STDIO is the standard input output protocol. I don't think it's a protocol. It is the way in which the communication happens between server and client, especially when they are running on the same machine. HTTP or SSE or even socket, WebSocket happens when there is a network in between. And let's also see this React loop. I just want to show you how the actual thought, reason, action loop looks like. So let's say this is the question: what missions are currently in transit? Okay, and let's just run the step. So the thought the LLM has is the user wants to know about the missions currently in transit. I should search for missions with status as in transit, not status as delayed or not status as aborted or something. Then based on this thought, so this thought is basically the reasoning part of the LLM. The action that is taken is call the function search missions, and the query that is passed is the argument that is passed is query should be in transit, status should be in transit. Then after this action, you will get some results. So where is this results coming from, by the way? Where is this coming from? It's coming from the server, right? MCP server will have these results which are passed into the MCP client, and LLM will get access to that. And based on this observation, there will be another thought. I found one mission out of all the missions. It found there is one mission in transit, Mars Pathfinder Relay. I have all the details I need to answer the question and then show the answer. So the final answer which user gets after user, there was a thought part here, which is the reasoning. As part of it, there was an action. As part of it, there was an observation. Then that resulted in another thought or reasoning. And then finally, you have the answer. Then this is the most basic part. But if there is multi-step, the LLM can do this more number of times. So let's say this is the question. Can we launch ISS resupply Delta on March 10th? Check whether the cargo, check the weather and cargo weight, then estimate fuel. So first, the thought is user wants to know if M003 can launch on March 10th. I need to check the weather. I need to get the cargo manifest to calculate total waste and estimate fuel. Then tool will decide first, okay, first get weather forecast. Weather forecast for Cape Canaveral. And this is the date, March 10th. Then observation is you get this thing. This is the observation, partly cloudy, wind speed is so much. Then the thought is, okay, weather is good, so launching is safe. Because if launching is not safe, you don't even have to call the next function, right? So if the weather forecast is very bad, you don't even have to call the get cargo function or the estimate fuel function. So weather is good, launch is safe. Now I need to check the cargo manifest. Then the action will be check cargo manifest function. So this function is now called. This function will return the next observation. The observation is for the current mission ID that we are discussing. What is the cargo status? Then the thought is cargo's total is 435 kilogram. Now I can calculate fuel estimate for this particular payload. Then the next action is for this cargo, for this particular mission. So the destination is to the International Space Station. What is the expected fuel consumption? Then the next step is, as a result of this action, there is this observation, which is the result coming from the MCP server. And then on this result from the MCP server, there will be a reasoning loop. And then at the end of this reasoning, it will say, okay, mission is safe. I can go ahead. The fuel estimate is cargo size is 435 kilogram weight. Fuel estimate is this many kilograms, $100,000. So this is how after 3 loops, right? So first loop, first thought action observation loop was this. Reason action observation was this. Second was this, these 3. And third was this. And only then it ended up with the final answer. Sometimes it can, for this React loop to implement, we need to call reasoning models, or regular LLM models will work. I think for this, we'll have to use reasoning model with its capability. Otherwise, the regular models will keep on giving you its output, right? It should have an internal reasoning capability. Otherwise, it will keep on relaying its output to the user. There is another one, update the Venus atmosphere probe mission to completed status. So here the thing is, if it's an aborted mission, it should not be changed to completed status. So user is asking something that is impossible, not impossible, that is something that should not be done. So the thought is, in the React loop, the thought is the user wants to update the mission status. Okay, first let me find the mission ID. Then the action is search missions. Then observation will be all the missions are available. The ID is available from the particular mission name. And then I will try to update it to be completed. Then it should write a function, update the mission status, and mission ID is provided, status equal to completed. But then success is false. Error, invalid status transition, cannot move the status from aborted to completed. Always allow transition from aborted is none. So basically, aborted mission status cannot be changed. So this is now the observation. Basically, it's an error. After this, there is nothing. So the update failed because aborted is a terminal state. You cannot transition from aborted to completed. So cannot update M008 status, transition from aborted to completed is not allowed, and aborted mission cannot be marked as completed. So basically, the agent can go through different scenarios and reason and tell the user what to do. Now look at the token consumption. Obviously, the downside of React is token consumption is high, but then in mission critical applications, it will be very good to have a React loop. In fact, in many cases, how many of you have used Paper Banana for making figures? Have you heard of Paper Banana tool? I think I had mentioned it in the first lecture or something. Basically, it's an amazing tool. It's an amazing tool to create figures using Nano Banana. But however, Paper Banana itself came out as a paper, by the way. So this is the paper. This is from Google. I think it's from Google DeepMind, if I'm not wrong. Okay, not sure DeepMind, but Google Cloud AI Research. But this paper, what they did is they did not build a new model, but they built an agentic framework around Nano Banana to create amazing quality figures. So just check this. So basically, this whole figure was created using Paper Banana itself. So this paper was written most of the part using Paper Banana. If you really want to try the implementation, I have made a banana.vizuara.ai. You can just check this link. Here you will have to paste the description of your figure and just paste your API key. And then you can generate amazing figures. Just check this website. But what I'm trying to say is, here also they have the same loop. There is a agent who will critique the initial iteration that is created. Then there is a thought process where what are the mistakes, what is the difference between what the user has asked and what the generated output is. And it will create 3 outputs. You see this iteration 1, iteration 2, iteration 3. And over each iterations, it will try to make the output better and better and better. And it's actually very mind-blowing. You don't need actually this website to implement Paper Banana. If you have Cloud Code, just give the this Paper Banana GitHub LLM research. So just give this link. It's a public repo. Just give this link to Cloud Code, and Cloud Code will figure out how to invoke Paper Banana using pip install Paper Banana. So the instructions are given here, but you don't have to necessarily give this to Cloud Code directly. You can just refer to this GitHub. But basically the point is, here also they have implemented something very similar to React loop, where every single action that is done on Nano Banana is evaluated in the next loop, and then it iterates. And because of this, the token consumption is higher. It consumes maybe 3x or 5x more tokens than normal, but the output is significantly good. So, and then this custom query, I want to try this. Which missions are scheduled to happen in the next 3 months? I'm just running this. So here an LLM is being utilized. So I have given Gemini API key here. And the thought, so this is now the actual loop, right? So the thought is the user is asking for missions in the 3 months. So search mission tool is the most appropriate. Then the action is that tool is called, observation is all the mission IDs are now available. And then the thought is I have received the list, and then we need to find whichever are from the next 3 months. So in the thought loop, it will see that these are from the within the 3 months. This is also from the within the 3 month. Okay, here one problem that has happened is I have defined the maximum token length so that my API, my Gemini API usage is minimized. That's the reason why the output is truncated. But otherwise, if I don't, keep the token limit, you will see the full output. So this is the React loop. One thing we can do is, can we come back to this quiz and let's go through the first 15 questions. We had skipped this in the beginning. So yeah, I will share the code base also to the, you mean the Vercel app as in the Vercel app for YouTube, this maker, right? YouTube transcript maker, right? I will share that, yeah. So let's do this. In the tool lifecycle pipeline, describe, decide, call, return, reason, which stage is most impacted by the schema? So think about where the impact is coming. Impact is coming in the LLM's decision, right? So LLM's decision is what? LLM's decision to invoke which tool. So this is the most impacted part of having a poor quality schema. Next is, which of these is the best tool name following function calling conventions? Obviously, the search mission, this is the convention. I don't see what's wrong with this one also, mission search, but it just so happened that something, I mean, sometimes there are certain conventions which emerge eventually. Right now, this is the convention. Maybe tomorrow it will change. Who knows? A tool schema has 8 parameters, all marked as required. What is the most likely problem this will cause? So basically, all the parameters we are saying all are required. None of them are optional. This we discussed earlier. So the problem is this, right? You are saying, telling the LLM that, hey, something, you have to put something here. You can't leave it empty. This parameter cannot be left empty, which means you are forcing the LLM to come up with some parameter or something to insert. And this will, if you are forcing the LLM to do something, it will do something. And which means hallucination can happen, right? It's not that the tool may execute slower, because some default parameters might be already inbuilt in the tool, which means even if you don't pass it, the default parameter will be taken. So it's not about whether tool will run slow or not. Why should tool schemas use enum constraints for parameters like status instead of free text strings? Same logic. If you are providing free text strings, you are allowing LLM a lot more window of exploration, in the sense that LLM can come up with any output. But if you say output is from one of these, you're forcing it to pick from one of those. It will pick from one of those. Enums prevent LLM from hallucinating invalid values. It will not say get mission status instead of failed and something like that. Mission status cannot be something like upcoming or something like that. So it will prevent LLM from coming up with random values. What are just-in-time instructions in the context of tool use? So we saw that the JIT instruction earlier was part of the tool's return value, right? And that will help the LLM figure out how to interpret and present the result. But JIT can also be in the other way. JIT can also be embedded in such a way that LLM can add it as part of the tool call also. So it is a guidance that is embedded. So somebody has mentioned lazy loading, a system prompt technique, that lazy load tool descriptions only when the tool is about to be called. So the thing is, JIT comes, it is not to call the tool or something like that. It is to get the tool description. What are the required to the other JIT which we discussed, not the one from the results. If the JIT is part of the result, you are looking at how LLM can interpret this result so that the next action can be taken with least context consumption, right? It's not about it's not just about lazy loading. It's also about I'm not sure if lazy loading is the right term. Somebody had mentioned if B could be the answer. I'm not sure if this is the right way to interpret the just-in-time loading, a system prompt technique that lazy load tool descriptions only when the tool is about to be called. Because you need to know what tool to be called in the first place, right? To get the description. So JIT primarily allows for that. And then using RAG, you can get the description corresponding to the tool if the descriptions are stored elsewhere. Then you are designing a safety critical fuel estimation tool. Should you put safety instructions in the tool schema description or as JIT instructions in the return value? Where should it's a safety critical fuel estimation tool. So fuel estimate should never be wrong. So where do you put these instructions, JIT instructions? So you can put it in both. The reason is, let's say the fuel value is low. Corresponding to that low return value, there will be some JIT instruction which comes as part of a if else if ladder. So you can have if the fuel value is less than this much, put this as the JIT instruction. If fuel value is greater than this much, put this as the JIT instruction. Else if fuel value is so much, put this, right? So JIT instruction can be added in the tool results using a deterministic if else if ladder. Plus you can add some in the tool schema description, you can add some guidance about if the value happens to be less than this, delay the mission until the fuel issue is resolved or something like that you can add. So the answer is both if it's a safety critical application. In the React, which is reason plus act pattern, what is the purpose of explicit thought step before each action? So basic idea is this: LLM needs to improve its own context to decide what tool to call next. So when you add a thought part, explicit thought part in the React steps, what happens is you're essentially consuming a bit more number of tokens, right? You are saying you're forcing the LLM to think. And as a result of that thought, some tokens are being generated. Those tokens are added to the window, context window. And that the total set of tokens are now added back into the LLM to decide the action. So what has happened as a result of thought is the LLM has produced an output based on the tool result or based on the observation. And then LLM now have a broader context to decide what action to take next. So on one hand, it consumes more tokens, but on the other hand, the tokens that are generated as a result of the thought is of extremely high value. So those valuable tokens are now added into the context before deciding what action to take next, right? So it forces the model to reason about what tool to call. Then another one, a weather tool returns launch safe is false. JIT instructions is critical. Do not suggest waiting for weather to clear. Policy requires 48-hour clear forecast. Meaning, if the launch safety is false due to weather issue or something, you need 48-hour clear forecast. So that is the JIT instruction, just-in-time instruction. An agent without thought, without the thought step in the process, will say the weather is bad, but you could try again in a few hours. So in this case, what has went wrong? So the question is, JIT instruction clearly says, like, look at our own reasoning. Our reasoning is when we see this JIT instruction, it clearly says you need a 48-hour forecast, clear forecast to even decide whether you should launch. It's not like whether currently the bad weather is bad, you again check whether you can immediately launch. It's not like that, right? So this JIT instruction is clear. So, but then why did LLM not get that clarity? it did not get the clarity because as soon as it received this launch safe is false, it thought, okay, it is not safe to launch right now, which means weather is bad, so you could try again in few hours. But that is because of the absence of thought step. If there was thought step, it would have reasoned that, oh, the JIT instruction says that you need a clear 48-hour forecast. So you need to first look at the weather forecast now, if such a tool exists. And then if that tool is giving us a response that till the next 36 hours weather is not good, but after that you have a window of 96 hours of clear forecast, so maybe we can check again after 36 hours, something like that. Then it would ideally make another tool call before giving the user this response, right? So what has happened is the agent skipped explicit reasoning and didn't process the JIT constraint before generating the output for the user. Another one is an agent tries to update a mission from aborted to completed. This we saw this example, and receives an error, invalid status, invalid status transition. Aborted is a terminal state. What should the agent do next? So now this is the observation, right? This is the observation. After this observation, because it is a terminal state, there is no other action to be performed. The only thing is you reason based on the observation, and then based on that, you provide the user an output, or you say what the user should be understood. Like you should understand that aborted mission cannot be changed in status. Then a few questions about MCP, just 6 more questions. In the MCP, what are the 3 primitives? This we have already discussed: tool, resources, and prompts. Very easy. Then in MCP, who decides when to invoke a tool versus when to include a resource? I don't think we have discussed this. When to invoke a tool is decided by whom? Is it the client, or is it just the when? You can answer instead of ABCD. You can just answer who is deciding when to invoke a tool. It's the LLM, right? So LLM. See, think about this. When we were building a 3D model in Blender, the only instruction that I gave is make a spring mass damper. Now the LLM has to decide, should I put a spring first, or should I put this thing, add color to the spring? Should I add a camera? Should I add lighting? Right? So these are all different tool calls. We did not explicitly say that, right? Cloud Code also cannot say that. Cloud Code is not the brain. The brain is ultimately the LLM. Now think about this. The order of the tool call is very, very important. The order in which tools are called will decide the final output. And who decides this order? LLM decides the order. It's not the client. Which tools should LLM know about? That is decided by the client. So here, model decides when to call tools. The client application decides when to include the resources. The resources, and where are these resources included, by the way? Where are the resources included? Client is the one who is including it, but to where? The resources are finally, at the end of the day, it's loaded to the LLM's context, right? Part of the resource or full resource. So the client can decide, hey, I need to implement a keyword-based RAG to fetch the appropriate subsections from the, let's say, cloud.md file, or let's say from a JSON file, to include it in my context, right? So client decides that before it is passed into the LLM's context. Then based on all of that, LLM will decide, here is my current context, and based on this, these are the tools that I need to call in this order. All right. Next, what transport does MCP use when a server runs as local subprocess, similar to Cloud Code controlling the this Blender? It will be stdio. Then during MCP initialization, the client sends an initialize request. The server responds with capabilities, and the client sends notification/initialized. Why is this 3-step handshake necessary? Meaning, why should why should the client first initialize, then the server responds, and then client sending this notification/initialize? Why is this 3-step needed? 3 step needed? 3 step needed. 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 3 step need And this is called as the initial client server handshake. The reason why this handshake is needed is because if this is not there, LLM has no idea what all tools are existing on Blender. So my Opus 4.6 has no idea what tools exist on Blender. Maybe some new tools are added. So the initial handshake between my Claude Code and Blender has to happen so that then the Claude Code can tell, hey, here are the tools and descriptions that the Blender has in a token efficient way. So basically, it lets both sides know. It lets the server know that this client is communicating. It lets the client know that from the server side, you will have access to these tools. An MCP server exposes 15 tools, each with detailed descriptions. What is the main risk of having too many tools? The risk of having too many tools is these too many tools. If the client is not doing a good job of passing the tools in a good way to LLM, if with too many, actually here there is one, in my opinion, the question should be an MCP client exposes 15 tools from the server. That's the better way to word this. But at the end of the day, what will happen is LLM will get confused. So here we should say something is exposing 15 tools to the LLM. Basically, MCP client exposes 15 tools to the LLM with a detailed description. Where is MCP client getting information about the tools from? It is from MCP server. So ultimately, it is coming from the MCP server only. But the better wording of this question would have been an MCP client exposes all the 15 tools it got from the MCP server with detailed description. The risk is model will get confused due to context rot. Then this is the last question. In a React trace, an agent chains get weather forecast. Following that, check the cargo. Following that, get the fuel estimate. Each tool result is adding tokens. Why does tracking cumulative token consumption matter? Same thing, basically. This, as I showed you, see, even my result got truncated earlier. So you could exceed the context window. Even if you are not exceeding the context window, your context may rot. So this is the issue. So this is the end of the quiz. Now I want to give you a homework. Okay, so now it is Thursday. You have 3 days to finish this. So homework will be deadline will be on Sunday late night. So the homework will be about building a model context MCP server and client, hosting it yourself, and sharing the link where I can test the client. The application can be anything. I don't care what the application is about. It can be something simple to something complex. But I will provide a detailed description of this homework, which you can take a bit of time to work on Saturday. I will really appreciate it if I can already make if you make it in such a way that it also allows for Gemini and OpenAI API key. You don't have to give the API key or something. I can use my own so that I can test this. So this exercise will in this exercise, if you want to include RAG for whatever reason to contain the token consumption to a certain limit, you can add that. But my primary thing is what I want to do is I want you to either implement your own MCP or figure out the secondary option is you figure out how to connect to an MCP server of an application which you use on a daily basis, okay, which is part of your job or something like that, and then record like a 5-minute video where you show how you connected the how you build the MCP client and how you connected the MCP client to the server, and with this, what are you accomplishing? Like what task are you automating? The more value added this particular MCP server is, the better. You don't necessarily have to build the server. You can use existing servers others have built from internet, from GitHub or anywhere, doesn't matter. But show the utility of this application, show why this is so important, and also tell me in what industries can this cause some sort of disruption. All right. So this detailed homework description I will put in the assignment section as part of today's session. This is session 4, right? As part of session 4 material, and you will have 3 full days to work on it. All right. So we will next meet on Monday, same time. Tomorrow we don't have a lecture. One more update is that regarding the Thursday's build lecture, I will confirm the timing and the date, whether we need to take it on Thursday or whether the duration, because it will be a long lecture, should we keep it on weekend? That I will confirm sometime early next week. So we will meet again next week. You can post your discussions and everything on Discord, or you can even email me. But please don't forget about the assignment. I will post the assignment and I'll put a reminder on Discord. But I really hope you all will get some time to work on it. It will not take you more than something like this, let's say max to max 3 hours. So you can split it such that 1 hour each day. If you can spend on Friday, Saturday, Sunday, that'll also be more than enough. Sometimes it won't be even costing you 3 hours. But just try this activity to build a very useful MCP server client framework where you think it can add tremendous value to some industry, right? Or to your own workflow. And you can share one of the two things. Either you can share a Loom video recording, these descriptions I'll post, or you can give me a link using which I can just test it out. All right. So thank you so much again for staying back in a long lecture. Have a good weekend. Saturday, Sunday. We will get back again on Monday. Quick question: does MCP result count part of output token? MCP result meaning does everything from the server, is that counted as part of the tokens? It is not, because client is ultimately deciding what goes into the LLM's tokens, right? So that is under the control of client. So thank you so much. Please build. This weekend is a build weekend. So I'm really expecting something mind-blowing. I really hope I can find some gems among you who will build something and truly inspire me. If there is something which you build amazingly, we can even collaborate together after this bootcamp is over. So please put your heart and soul into it, and let's see what you can come up with. Anything does not matter. The complexity does not matter. But if the value proposition of what you're showing is something really interesting, we can figure out ways to collaborate. So thank you so much, everyone. Let's meet on Monday. And for whatever reason, if you need a little bit more time for this exercise, just drop me an email. I'll be happy to respond to you. Thank you so much. See you next week. Bye.